So we have good bacteria in quotes, and then bad bacteria also in quotes. The good bacteria do not cause harm, so we call those non-pathogenic. And then those that can cause diseases, we call them pathogenic bacteria. Okay, so diseases, for example, in humans, TB, which is tuberculosis, typhoid, tetanus, cholera, syphilis, gonorrhea, all these are diseases caused by bacteria. Okay, and they are able to cause this bacteria because of the future that they have. The pili, they help in attaching the pili or the fibri, helping attaching to the surface of the host. The flagella also allow them to move, and then the toxins aid in making sure that they cause damage to the cells and then causing the disease eventually. So the flagella, like we said, they're very important for movement. The pili and those structures that help in attaching. I think this one will just cut into, right? Yeah. So we said that the bacteria are actually identical. Okay, in terms because of how they in terms of how they divide. Okay, through binary fusion. So we have two daughter cells of daughter bacteria that are similar. So what actually makes them different and be able to survive later on? So this is where we bring in the concept of genetic recombination. That, for example, for humans or other animals, you have meiosis as one of the ways of introducing in what we call variation. Okay, sexual reproduction results into variation. And we say variation is very good for ensuring survival and evolution, therefore. So how do the bacteria achieve that? The bacteria have mechanisms of obtaining obtaining DNA from other bacteria or even from the environment. So there are three main ways. Conjugation, this is where you have DNA being transferred from one bacteria to the other through a connection that we call the pillars. Okay, there is a pillars that connects the two bacteria, and then genetic material is transferred from one bacteria and one bacterium to the other bacterium, right? And then we have what we call transformation. A bacteria can pick DNA from the environment or even from dead cells. Okay, and then it can also get DNA through what we call bacteriophage. Bacteriophages are bacteria that are viruses that have infected bacteria. Okay, so that means that you have a bacteriophage that injects part of its DNA in another bacteria. It injects its DNA in other bacteria. Okay, so that is transduction. So that means that getting new DNA means that it boosts its characteristics and its adaptation to be able to survive. Okay, so issues to do, for example, like bacterial resistance, antibiotic resistance. Okay, where we have bacteria resisting antibiotics. This is to say that the bacteria are no longer being killed by the usual antibiotics. So even if you fall sick, you get the hospital, you're given these antibiotics, you still don't improve. This is because the bacteria has gained resistance. Okay, so this is what happens with tuberculosis, for example. The microorganism that causes tuberculosis, Mycobacterium tuberculosis, can be resistant to certain antibiotics. Okay, so they can develop resistance, and that's why a patient with TB, we encourage them to take their medications as prescribed, because if they don't, they will get multi-drug resistant TB, and that is a problem. Some of the bacteria can resist action of the antibiotic by having an extra substance on them. That substance prevents the antibiotic from acting, and that's what we call biofilm. And then we have another survival mechanism that the bacteria do have. They have what we call bacterial endospores. The endospores, these are highly resistant structures that cover the cytoplasm and the chromosome. And this allows the bacteria to survive in very difficult conditions, drastic or extreme conditions of heat, ultraviolet radiation, desiccation. Okay, we have what we call anthrax spores. Okay, the anthrax spores can actually cause infection even after years and years. Okay, and then we have botulism spores. These are also these spores that can cause food poisoning even after a long period of time. And then another characteristic that is worth mentioning about is the issue to do with staining. When we want to know the characteristic or what makes up the bacteria, we can perform what we call gram staining. Okay, with gram staining, what this basically means is that you get a stain, which is basically a dye, and then apply it to the bacteria and then see what happens. Now, we have what we call gram stain, gram positive bacteria. Okay, gram positive bacteria. When you have gram positive bacteria, it means that when you apply the gram stain, the bacteria will appear purple. They will stain purple. Okay, that is gram stain bacteria. Gram positive bacteria, they stain purple with gram stain. They lack an outer membrane that makes them more vulnerable to certain antibiotics. And then those that are gram negative, they stain pink with gram stain. And this is because they have an outer membrane that is made up of lipids and polysaccharides. So the outer membrane makes them resistant to certain antibiotics. For example, is being resistant to penicillins. And also some of them have enzymes that break down the antibiotic, so that the antibiotic will not actually work.